We started in 2007 and completed in 2010 in one of the fastest airports in the world, even today, till today. So if you go to 1970s, and one of our initial construction phases, which started in 1944, in 70 we had done the first commercial building, which is a National Stock Exchange, which you see in the background. It's a 30-story construction and 120-meter height. And we got an early glass curtain walls, which was very rare at the time. We had done a slip form construction for RC walls. At the time, jump form, slip form at the initial stages of it. And the core we have finished in 35 days just. That's a exciting thing about any slip form construction. We have thin steel mullions. Some of you remember, SOM, Skidmore Owing Merlins. Fazlur Rahman, one person is there, he's from Bangladesh, who is the expert in structural steel. And he did the design for the WTC, World Trade Center, which is collapsed afterwards because of all the attacks. He did the concept called tube in tube. So he placed different heights of tubes in different floors and started amalgamating into different towers. So that is the front of thin mullions and thin steel columns. So similar complexity was given for this building as well in the 1970s. And it's called a matchstick column concept. That's the architecture vision, and it is also, we have done that construction at the time. And coincidentally, I'm born in this year, so I'm not part of this construction, of course. So 1980s, our another landmark building, it's called Baha'i Temple. It's a just 45-meter tall building. We have done the wind tunnel. It's a lotus petal. It's a blooming lotus petals. So normally civil construction, some of you know, the RC walls require a tie bar, which is to avoid the ply, because we use a ply for a formwork, and ply, if it goes beyond 1.2 meter spacing of support, it gets bulged up because of concrete pressure. To avoid it, to put a tie rods. But here we didn't put a tie rod in this particular building as early as 1980. And we have done the pre-cut polished marble as a cladding on top of it. And everywhere it's a fair face concrete inside. So outside is a marble cladding, inside is a fair face concrete. Geometry is a little complex. Most of the senior directors at this moment are part of the project site at the time, 1980s. And the white cement we use there for the concreting purpose, because that's why if you look at it in the morning time, next time we'll see if it comes up. We have formwork done as a radial circumference tracer, because normally I said I require a tie rod for the supporting the ply. Here, though we have put the ply, we have gone for a circumferential trusses to hold the pressure of the concrete. That's why it has got an excellent form finish now. If some of you have seen all this monument, it will be wonderful to see actually. You will get a lot of solace when you sit inside this, 32 meters height bottom clearances. Traveling to 1993, within Chennai, we had done our Jawaharlal Nehru Stadium. In 260 days, the construction was completed. We got a complete precast seating. Precast, we call it as a rackers and bleachers. The system is done completely engineered in Chennai, and we done the erection within record time of 260 days. It was a target given by, at the time, Chief Minister Dr. Jayalalitha. Fastest construction, around 90s what we see, where would we done the design, demolition of existing stadium, design and construction. All this is 260 days. We have done the pylons. If you see the pylons here, you can see it is integrated. These are the pylons for light holding. These are erected on top of the precast members, which are supported back by the, again, precast columns. A lot of resources, of course. We used to have at that time 2,500 persons for this site to do it in record time as well. So traveling to 2010, we started in 2007 and completed in 2010 in one of the fastest airports in the world, even today, till today. Fastest airport construction, Delhi International Airport T3. We have done in 36 months EPC, Engineering, Procurement and Construction. This is a complete, they get a concept design with an approval for the price, and then we carry out the balanced engineering perspective from the concept to the schematic to DD level, and issue the construction drawings and ensure the procurement happens as per the timelines required, and had a construction support as well. It's a 25 million passenger capacity and 25,000, you see the number of workmen, 25,000 workmen working on the site. We have around 18,000 tons of roof truss, which we erected using strand jack. Strand jack is nothing but a jacks fitted with a hydraulic oil and lifted as a whole. So we fabricate everything at the bottom and lift it to the roof and transfer it into the columns. That's a strand jack system which we employed in many other projects, including our dial. Overall 5.5 lakh square meters of footprint, and we have got 4.3 kilometer runway as well as part of the scope at the time. And what are the technology enablers at that time? In the past, we used to have low-rise buildings. We have a cast in situ with conventional formwork, which is vertical formwork, horizontal formwork and all. Reinforcement tying, another laborious work. It involves a lot of working people. Even lift used to be manually used to be done. You used to put four ropes and lift it and carry the lot of bricks which are 36 kg weight. And compactors, people used to go on top of the concrete, walk in the slushy concrete of green concrete and then vibrate it, because it cannot neither avoid vibration nor it can have over vibration. It has to be sufficient vibration. Most of you know if concrete technology. Conventional scaffolding, as I said earlier, and design and drafting used to be manually. We spoke about tracing papers as well. And batching plant used to be very, 3-4 funnels for the material storage. Presently, what we're doing. So in 2023, we started this project called IACC, Indian International Convention Center in Delhi. It's around 89 lakh square feet, 90 lakh square feet of building. Largest LED media facade of 10,500 square meter. I didn't put the picture here, but yes, that's the largest in India. And 2,500 visitors can occupy the seats, and we got 3 exhibition halls in the same. We have a 3D GRC. Normally, GRC is glass reinforced concrete. And here we have produced 3D form of GRC. It has got protrusions in a diamond shapes, which comes out if you see the facade and the location. It's around 30,000 square meter, massive area and the elevation of the cladding. We also have gala venue, which is retractable seats. For example, these seats are fixed, right? In that auditorium, what we have done, the seats are retractable, which means I can roll down all the seats and make it as a complete floor for using for other purpose than the seating alone. That's a latest technology which is incorporated to use a multi-purpose type. So which we have done there. 2025, we got an opportunity to serve the government's project as well in large way. This is called CCS 123, Central Secretariat Services. So this is in Delhi, near Luting Gardens as well, 4.5 lakh square meter built up area, and has got 18,000 capacity of work people. In this, all the Home Ministry, all the ministries will have a seating in this particular 3 buildings. We finished in the last December. Its area is almost equivalent to 13 football fields. Normally in US they measure it as equivalent to football fields as well. We got a stack car parking for the basements for each stars, and each accommodates around 8,500 staff. And one of the important milestones for us attached to this project very well, we started in 3 years back to do a design of 1,000 years life. It doesn't have any single iron bar, no steel used. It has got roller compacted concrete. We got a lot of stones called Dholpur stones. And these stones are all completely fixed with copper pins. The bonding is done for the shear. It is designed for almost Richter scale of 7 for seismic intensity. And it can take that story shear, which are the shear coming for the seismic activity. And we have got a 21 feet height of a plinth. We have excavated 21 feet and done the concrete in the layers of 125 mm for so many layers to reach the 21 feet. Because that base allows any oscillation coming to reduce the oscillation to the superstructure. And the pins designed for the copper pins are between the granite can hold that shear. It has got innovative foundation. We can say the roller compacted concrete RCC. So it is RCC again. It just look like artificial rock. 3-story structure. Got a 3. One is Ram Lala at the bottom, and second will be again Ram Darbar. Third will be one more space for putting the thing. Recently we got an opportunity to have our board meeting there as well. So in 2025 again, we have completed one of the monument. You can see the design behind this on the background. Anybody knows whose design is this? Architecture? There is no straight line in the building. Yes, excellent, good. So Jahad is known as an 89-degree architect. She doesn't know 90 degrees at all. She passed away in 2016 after creation of this monumental design. But her designs stay. Apart from this, one more building is the Baku Museum and also China's Beijing Airport as well. Here we got a 12 sculptural feature columns we have, and that the spans are 50 meter by 50 meter. All these petals are replication of a lotus petal. So this concept of the building is lotus flower petals. When you go inside as well, you see the monumental 50 by 50 meter spans, clear spans, cladded with GFRG, I'm sorry. And they are all supported with a trusses which are varying from 5 meters to 3 meters deep. So even the structural steel is so complicated in this building. Pleasure to be part of the projects as well. There are 370 meter long roof, and it has got a high seismicity as well and water table as well, apart from wind load. We done again wind tunnel analysis for this building and found out because this particular surface will attract a lot of wind because of tunneling effect. So you have to find exactly the wind pressure at every corner to find the facade design as well, apart from structural design. So what are the technology enables at the present time? We have BIM. We got a studio called BIM Srishti Studio in our own campus, where we ensure that all the projects running go through the review of the 3D studio within the BIM itself. So every discipline, name the discipline, architecture, structure, mechanical, electrical, plumbing, electric means ELV, any discipline is there has to be modeled in this. So you can see the Srishti Studio here. And another important point I just want to highlight here is the augmented reality. We go to the site and we got just a iPad there. We can just put an iPad in the front of us and you can see what will be the future services which can be coming at the location. We can imagine exactly how the sequence can be constructed. So the BIM we utilize for 3 parts. One is to ensure the clash-free model so that construction of all the services and the civil can be done well. Also, second part is with respect to visualization of sites. We model the sites and issue to the site for them to understand the sequencing part of it. So first, which service to be done, then what is to follow. Third will be quantification also can be done from this. So we use for all these 3 purposes. Future, what happens? We are going for reactors. We are doing a lot of data centers. Data center is big buzz. You would have seen the news of yesterday's Amazon data center being bombed as a target by Iran. But that is what the future will be, because all the data, whether it is Google or anybody in the software or banking system or finance systems, everybody deals data now. So data storage is most important thing. And we used to design data centers with a 8 kilowatt per rack. We measure in the kilowatt per rack. It has gone now to 40 kilowatt per rack and is going to soon go for 120 kilowatt per rack, which means the data what you store in a particular rack size, which is of 22 inches, it's so high. So we have got different technologies to cool. Once you put data, it gets a lot of heat, right? So how do I cool this data? I have to supply the power first. The power can be nuclear power itself will be supplied. And we also go for liquid cooling. So because the temperatures are very high for this, we go for a cooling by liquidity. We call DCLC, direct chip liquid cooling. NVIDIA coming is a rack capacity of almost 120 kilowatt per rack. We also have alternate energy called hydrogen powered data centers. We use BESS, battery energy storage systems. And we also go for seawater cooling. See, mostly the data centers are power guzzlers, meaning you got a lot of power to give. So how do you satiate the heat generated from the power generation is the question about seawater cooling. So we cool all the energy, all the heating coming up by the seawater cooling as well. We are employing this in one of the defense projects in Vizag as well. And NVIDIA is introducing quantum computing as well. So now we are doing one quantum computing facility in Amravati. First time I think Chief Minister there wanted to put a quantum valley. We are putting almost 256 cubic. This is the size and it looks like this. And it is being cooled by cryogenic cooling of helium. We are part of it, of course. We are constructing that now. Future is what? Semiconductors. Most of you know there are 2 factories. One is in Amsterdam, one is in Taiwan. So we are now in India is going well. Already you would have heard the news of 2 semiconductor factories already started. One more we are constructing in Dholera. So where we have got a fabs chips, we place bumping the copper on top of the wafers and produce the semiconductor chips as well. So what are the technologies enablers for that? You can see black masonry we are using in our own site of Innovation Campus, which is in Chennai. On the left, what I'm saying, the block works can be directly lifted by the machine and placed. It avoids human lifting and human transportation of the material as well. This is one thing which we are incorporating. On the right side, what you see is automatic plastering machine. Most of the workmen required to do these two jobs first. So we want to address these two concerns of our workmen. So this goes automatically to look at that location of the wall, and you can adjust thickness of the plastering. As you know, external will be 18 mm, internal will be 12 mm, it can be 10 mm as well. So it adjusts automatically and goes to the location. It lifts up and goes to the location. You can see how it pours it first cleans the surface and pours the concrete in that. So the application goes smooth. The margin of error is hardly 1.2 mm, which is quite fantastic for a working level. So it avoids a lot of workmen. That's our own interest. At the same time, it saves the time as well, because there is no quality concern, and also there is no time issues. We are also using rebar case robots to reduce the time. If you see this video, this is doing the welding. This welding is nothing but a tie bar, and also it places the rebar at the locations. So we are now employing here in 2 sites as an experimental basis, and we see the future a lot in this for that. Presently, we are doing the precast yards. So precast yards are very systematic. You don't have any limit. You have 2 gantries or 2 tracks on which you can mount this and run that. So this particular thing is catching up now, and these machines are still being not Atmanirbhar, but it is going from China. So we should have some technology for us to develop this in-house and use it at our own place as well. AI in construction. So automatic robotics to be employed here. We have a visual analysis of work quality, and you can see the pod on that right side. This walks in our site. We got a prestige site where we have employed this as well. So it walks and gives it identifies which is the cement plaster, which is the floor, and accordingly gives the specifications for that. And also it gives a checklist for the quality. How much it is off with respect to plumb, or how much it is yet to be completed. What is the quality issue you can find out from that. This chip, what is inside this robot, analyzes and gives the report for us. So that's the level of incorporation. Our aspiration is to make a digital twin from this, and also assess the quality through the scanning by lidar. So I think the last slide I'm trying to project. We have an equipment for AI, enhancing our team's performance for the P&M, reducing our workmen as well. AI workforce can be there, but it's not a complete replacement of manual workforce. You require still to check everything. And we also do the AI apps which optimize our project schedules to eliminate anticipated delays. Thank you for the opportunity. Thank you a lot.